Greetings to the viewer, this is Jashandeep Sethi right here, and in this video I'll be solving question 4 of MAT 104 Endterm examination. So let's begin. Okay, so the question that we have been given is to solve this ODE via two options. We have been provided with two methods via which we could solve this ODE. So I'll be using the variation of parameters method. So let me just write it down. Variation of parameters. So this will make it slightly easier for us to understand what we're doing. Variation of parameters, right? So one thing we know is that y is the sum of y homogeneous plus y particular. So the solution has two parts, that is a homogeneous part and a particular part. Let's just call this 1. Now we'll find the general solution for y double prime or double dash plus 9y equals to 0. So let's just call this 2. Now you might ask, why is this 0 here, whereas in the initial condition it was cosec? The reason for this is that in a homogeneous solution, the GT in a homogeneous solution is always 0, and for us our GT in the given equation is cosec. So for while calculating it for a homogeneous equation, the GT will become 0. So hence it will lead us to this particular equation. So let y homogeneous. Now since there is a cosec term, we assume that the solution will also have trigonometric terms. So we take it to be as a cos mx plus b sin mx. Right. So let me just y double prime. Let's just take a single derivative first. So y prime h is nothing but minus m. Let's just take m common. M a sin mx, it would be a minus sign, plus b cos mx. Right. Now we'll get m term in both of these, so we have taken the m term common outside beforehand only. Right. So now we'll calculate the double prime also of the homogeneous equation. So this would lead us to another m would come outside, so it will become m square, and inside we'll be left with minus a cos mx minus b sin mx. Right. So we can take the minus sign common outside, minus m square, and when we take the minus sign common outside, we'll notice that the term that is left, the terms that are left on the inside are nothing but our initial yh only, our initial y homogeneous. So this would become minus m square y homogeneous. Now let's just call this equation as third. So now what we're going to do is we're going to compare equation 2 with equation 3. That is, just simply put the value of y double dash in equation 2. So let's just write this, comparing equation 2 and 3. We'll just put the value and we'd be left with m square equals to 9. So this would lead to m is equals to plus minus 3. Now we'll reject minus 3 because sine q is not equal to negative of sine q. So the minus 3 would be rejected and we'd be left with m equals to plus 3. So thus y homogeneous is equals to a cos 3x plus b sin 3x. Let's just call this equation as fourth. Now we let cos 3x be y1 and sine 3x by y2. This would simplify things. So therefore, now this is a formula to calculate y particular. We have found out the y homogeneous and now we'll be calculating y particular. So this is nothing but y1 integration of determinant of w1 upon determinant of w dx plus y2 integration of determinant of w2 upon determinant of w dx. Here the w's are nothing but Wronskians. So the method of calculating Wronskians is pretty easy. They are as determinants. So let me just flip the page, right? So it will lead us to w equals to y1, y1 dash, y2 and y2 dash. So we'll calculate the determinant, right? This would lead us to 3 cos square 3x plus 3 sine square 3x, right? So we'll take out the 3 common and we'd be left with cos square 3x plus sine square. We'd be left with cos square 3x plus sine square 3x, which is nothing but 1. So it will be 3 into 1, which is basically 3. So we found out our w is 3. Now w1 is equal to, all we have to do is replace the y1 y2 with 0 and cosec x, and the y2 and y2 dash will remain the same. So this is now minus sine 3x cosec x. I think this is right. This seems correct, right? So now we'll find our w2. Here the w1 and w1 dash will remain the same, whereas we replace the y2 and y2 dash with 0 and cosec x. So this would lead us to cos 3x cosec 3x. I think so this is correct. It seems correct, yeah. So now what we're simply gonna do is that we'll just simply put these values of y1, y2, w1 and w2 that we just found out in this equation, in the y particular equation. So we'll put the values of y1, determinant of w1, w, y2, determinant of w2 and w, and we will solve further. So therefore y particular is equals to minus cos 3x by 3 integration of sine 3x by sine x plus sine 3x by 3 integration of cos 3x by sine x dx. Here also there should be a dx, I missed it out, dx, right? So actually the solution comes out to be quite long. When I solved it earlier, normally when I was solving the question, the solution came out to be quite long, so I'll try to write as much as possible. So this is minus cos 3x upon 3 integration of 3 minus, it is nothing but simple integration, although it is a lengthy one, sine 3x by 3, let me just put this in another line, plus sine 3x by 3 integration 4 cos cube x minus 3 cos x upon sine x dx, right? This seems correct. Yes, so what we'll this would lead to minus cos 3x by 3 integration 3 minus 2 plus 2 cos 2x dx plus sine 3x by 3 integration 4 cos x minus 3 cos x by sine x, and actually here should be another term, a minus term, but since there is no space I am writing in the next line, so that term is nothing but minus 4 cos x sin x and dx since it's being integrated. So actually this one equal to is basically in 3 lines. These are nothing but the 3 terms of the previous equation only. So this would eventually lead us to minus cos 3x by 3 integration from 1 plus 2 cos 2x, I think this is right, dx plus sine 3x by 3 cos x by sin x. Now here should be another term, but since there is no space I am writing it below, minus 2 sine 2x dx. Let me just check. This seems to be correct. Here it was this all, so then it would lead to this, then plus, this is correct, then sine 3x integration cos x by sine x upon minus 2 sine 2x dx. Okay, this seems correct. So it will eventually lead to y particular being minus x, cos 3x upon 3 minus cos 3x sine 2x upon 3 plus sine 3x by 3 natural log sine x, and there should be another term. Since there is no space I'm writing in the next line, sine 2x sine 3x upon 3. Let me just check. This is correct, then this is also right, then this is right, then the sine 3x by 3 natural log sine x plus sine 2x sine 3x by 3. Okay, this is correct. So now all we have to do, we have found out as the equation that we wrote in the very beginning, that y is y homogeneous plus y particular. So we'll just rewrite that equation, y homogeneous plus y particular. Now we have found the y particular, and we also found the y homogeneous earlier. Where is it? Where is the y homogeneous? Yeah, right here, y homogeneous is a cos 3x plus b sin 3x. So all we need to do is add this y homogeneous plus this y particular. So we'd land up with our answer, which is nothing but a cos 3x plus b sin 3x minus cos 3x by 3 x plus sine 2x, right? Yeah, this seems correct. And there would be another term, since no space, so I'm writing in next line, sine 3x by 3 natural log sine x plus sine 2x, right? So this is basically our solution, our y. Let me just check whether this is correct. A cos 3x b sin 3x minus cos 3x by 3 x plus sine 2x plus sine 3x by 3 natural log sine x plus sine 2x. Okay, this seems to be correct. So thus we come to the final solution. Let me just focus from the very beginning so you'll be able to see better and understand it properly. So this is the first page. Here we have the second page where we found out the wrong skin and integrated in order to find out the YP. Here also the same. Then in the end we simply just added the Y homogeneous and the Y particulate in order to find our final solution, in order to find the final answer. So I guess that is pretty much it. Thank you for viewing. Have a great day ahead.